So hi guys, this is the editorial video of Codechef Long Challenge problem Dr. Chef. So let's look at the problem. So the link to the problem is given in the description, so you can have a look of the problem from there also. So what is given in the problem is we have been given n countries with population A1 till AN. Now we need to find the cures. So each cure can cure one infected person. So one cure can cure one infected person. Now due to the lockdown rules, what do we have a condition here that on day 1 we have X cures ready and we need to supply these cures to independently one country at one time, right? So we cannot supply the cures to multiple countries on a single day. We need to supply the cure to one country, one per day means, right? So per day we need to supply the cure to a single country, and on day 1 we have X cures ready. Now on the subsequent day, on the following day, what do we have is we have twice the number of cures that were delivered, right? So if we supply X cures and we cure X people on day 1, so the on day 2 what do we have is 2X cures, right? So the people which are cured on day 1 will be doubled by the vaccines on day 2. So if we cure 5 people on day 1, now on day 2 how many vaccines do we have? 10 vaccines, right? So this is the meaning of the statements. And chef cannot supply the leftovers from the previous or the earlier day. Suppose we have 20 vaccines and we cure 10 people. A country has a population of 10 and we cure 10 people. So we cannot send the leftover 10 vaccines on the remaining day. So we cannot send the remaining vaccines on any country to the next day as it expires on the same day. So this is one condition. The number of cures delivered to some country on some day cannot exceed the number of infected peoples. So the number of cures cannot exceed the number of infected people. It is obvious. So however, coronavirus is not giving up easily. So it can infect a cure person that comes in the contact with the infected person again. So that means on each day the population of a country doubles, right? After the cure has been done for that particular country. So if the country has a population of 20 and we have cured 10 people on day 1, then again on day 2 the infected people will be 20. Why? Because the rate of infection is double. So the 10 people who are infected on day 1 will again infect the remaining 10 people, right? So the rate is also getting doubled on each day. So what do we need to find? We need to find the minimum number of days needed to make world a corona free. So we need to find in how many days, in how many minimum number of days we can make the world corona free. So this is about the problem statement. So now let's look at the example, how we can solve the example. Suppose we have an example of 5,5, the value of X is 5 and the area has been given 1, 2, 3, 4 and 5. So these are the population of the 5 respected countries. And what do we need to find? We need to find in how many days we can make this country corona free, make these countries corona free. So basically there are two important observations involved in this problem. So let us see the first observation. So the first observation states that skip the countries which have population less than half of the values of X, right? So if a certain country has a population which is half of the value of X, then skip that country. So why do we need to skip that country? Let's take an example. Suppose we have the value of X that is equals to 1000 and the population of the countries are 1 and 990. So this is the example that we are taking to analyze this point. So if we take the country with population 1, suppose we are delivering these 1000 medicines to this country which has the population 1, then the vaccine produced on the next day will be 2 because we have only cured one single person. So the next day what we'll have only 2 vaccines, and we are wasting 999 vaccines on day 1 because we are only curing a single person and we have 1000 vaccines on day 1. So we are wasting 999 vaccines. So this is not a perfect optimization that we were thinking. So how can we do this? We have wasted the vaccination. So how can we optimally use these vaccines on a certain day? So what we will do is we'll provide the vaccines to the country with population 990. So we'll provide this all 1000 vaccines to the country with population 990 and cure this country fully. Why? Because we have 1000 vaccination and the population is only 990. So we can cure all the members of this country by this vaccine on day 1. And now on day 2, what do we get? Now the total number of infected people will be 0 in this country. Alright, so we have cured all the people. On the day 2, how many vaccines do we get? Will be 1960. Why? Because we have cured 990 people. So the vaccines that we'll get on the day 2 will be double, that is 1960, which we can send to the remaining country, that is this country with population 1, and the infected people is only 1. So we'll send this, and in 2 days we can cure all the countries if we have initially 1000 vaccines. So this is the observation 1 that we can make from this problem. Now let's move on to the observation 2. So in this optimization, what we'll do, we'll cure all the infected person before moving to the next country. So if we are on one single country, then before moving to the next country, what we will do, we'll cure all the infected person of that particular country. So how we'll do this? So we'll have 2 cases. When x is less than array of I, that means the number of vaccines are smaller than the population of that country. And the second case is when x is greater than equal to array of I, that means the number of vaccines are greater than or equal to the population of that country. So let us take case 1. So if x is less than array of I, then here what we will do, we'll cure all the infected person, thus we will not increment I until x is greater than array of I. So what we will do, we'll first cure each and every member of this particular country, and until all the members are cured, will not increment I, that means will not move to the next country. In case 2, what we will do, since we have vaccines greater than infected person, so we can use the vaccines equal to array of I. So we have the vaccines and the number of people, and vaccines are greater than or equal to number of people, so we can use all our vaccines to cure these many peoples of a particular country. So we'll use these vaccines to clear this particular country. So let us take example of this particular observation. Suppose we have an array of population like this, 12, 19 and 20, and initially we have vaccines, that is x equals to 4. So now what we will do, we'll observe from this particular block. Since case observation 1 will not work here because the number of people, the number of population of this country is greater than the number of vaccines that we have on initial day. So the observation 1 will not work here. So we'll apply observation 2 over here. Okay, so if x is less than array of 0, so what we will do, since x is less than array of 0, so what we will do, we'll try to get all these vaccines delivered to this country and cure the people, maximum people it can cure. So it can cure at most 4 people. So now the number of infected people in this country will be 8, and now the x becomes 8. Since x, the number of people cured on day 1 was 4, so now on day 2 the number of vaccines that we'll have will 8, because the vaccines double itself by the number of people it cured on the previous day. So now on day 2 we have 8 vaccines, and now since we have 8 infected people on day 1, so the number of infected people on day 2 will be 16, and on day 2 we have how many vaccines? We have 8 vaccines. Now also x is less than array of 0, so on day 2 what we will do, we'll try to subtract this total number of infected peoples minus the vaccines that we have, that is 8 infected people are also remaining, and the vaccine will double itself on day 3, that is on day 2 it has 8 vaccines we have, and on day 3 the vaccines will be 16. Also the number of infected people will be doubled, so on day 3 how many people will be infected? On day 2 we have 8 people infected, so on day 3 we will have 16 people infected, and the vaccines that we have will also be 16. So 16 minus 16, how many people can be cured? All the population can be cured on day 3. So hence on day 3 all the patients have been cured for this particular country. Similarly, what we will do, we'll apply this approach on this country as well, with initialization of x equals to 16, and same approach for the country with population 20. So on the whole array we'll apply this particular approach. So this was the 2 observations that we can derive from the problem, and we can code these observations to get the perfect AC result of this problem. So let us see the coding part of this video. We are doing the same thing as we have discussed in the approach. So first thing is we'll input n and x, and we'll make an array of n and get the input in the array. So now what we'll do, we'll sort the array, because we are taking the countries in a sorted order. First we are checking that whether the population of the country is less than equal to x by 2, that is the number of vaccines, and then we are making the second observation. So we need to have the country in a sorted order. So we'll sort the array, and we'll maintain a variable total and I equals to 0 for the ith index country. So while I is less than n, and twice into array of I is less than n, so is less than x, so we are making the same condition here that we have discussed in observation 1, that if the country has the population less than the number of half of the number of vaccines, then what we will do, we'll increment it and we'll increment the total. So we can cure it in a single day. If we have the vaccines which are, we will increment in the vaccines, like we'll increment it twice, thrice, and 4 number of times. So we'll increment it and we can cure this particular country in a single day after we'll traverse back from the maximum country that we have cured. So if we traverse back from the maximum country that we have cured, so we can cure this country in a single day. So I'm incrementing total as well as the number of countries, the indices of the countries that I am taking. So this is the condition that we have discussed in the observation 1. So I am writing a while loop over here. While the countries with this condition are matched, so we'll increment I and total. Now let us see the second condition. So in this condition, what I am trying to do is, I am trying to match the whole process, that if x is less than array of I and twice of array of I minus x is greater than equal to array of I, then what I am trying to do, I am trying to match this situation that x equals to twice into x. Why? Because if the condition is that the country has a population which is greater than x and the remaining cured people, the remaining infected people is greater than equal to array of I, then what I'll do, I'll simply double up the vaccines each and every day. So while this whole population is cured, till the whole population is cured, I'll double up the vaccines and continue the loop. If array of I becomes less than equal to x, that means the number of population, the number of infected people is less than or equal to the vaccines that we have, then what I will do, I'll make x equals to array of I. That means we have cured these many people and now the value of x will be array of I, and I am simply increment the country. I'll move on to the next country. So while the whole population is not cured of a particular country, I'll cure it by doubling the number of vaccines and the number of people that we have on the number of infected people that we have on the previous day. And if the population of the country becomes less than or equal to the number of vaccines, and simply make x equals to array of I. That means I'll I'll make x equals to array of I so that we can double it for the next country, and I'll increment the indices of the country. At last, what I'll do, I'll produce the result as total. Why? Because we are taking the number of days in the variable total, so we'll produce the result as total. So this was the approach of the problem, Dr. Chef. So if you want to learn dynamic programming, so I have made a 15 days dynamic programming tutorial in which you will learn the different concepts of dynamic programming, like states in dynamic programming, memoization, how we can apply that in particular problems for competitive programming. So you can have a look at dynamic programming series. And if you want to learn graphs for competitive programming, I have also made a series for graphs also. So you can also learn graphs for competitive programming. The link to these two series is in the description, so you can have a look at it. And at last, please do like, share and subscribe my channel. Thank you for watching.